Hi guys, it's Ms. Caspero again. This is the last part of the modeling of the composition of functions. This is the modeling part. This is the part where you find out why you have compositions of functions anyway. But these are real life examples that would happen that you would be doing compositions of functions. A local electronics store is offering a $100 mail-in rebate along with a 10% discount. Let X represent the original price of an item in the store. What composite function would be needed? Okay. A coupon for $5 off any meal states that a 15% gratuity will be added to the total check before the $5 is subtracted. What composite function would be needed? All right. Well, here's the type of thing that you're doing. X represents the original price of an item in the store. So if you get a 10% discount, you would take the regular price, which is 1 whole price, minus 10% of the price. So you'd have X minus 0.10X, which would be 90% of the price. That would be the first function that you'd be dealing with, taking 10% off the item. The second thing that you'd be doing is taking $100 off of the price once you got it. Okay? So, of the f of x there. So what you're dealing with is you're going to do g of that 0.90x, and that's going to put that in. It wouldn't be f of x there. I had f of x. I meant x. Your g of x here, sorry guys, would be taking $100 off. X minus $100. Now, start up here in this. To do both of them, you'd have g of f of x, which is going to be g of 0.90x, because you had to take the 10% off. So this would be the function, 0.90x minus 100, that you could apply to anything that fell under this, the $100 mail-in rebate with the 10% discount. All right, this second one, a coupon for $5 off any meal states that a 15% gratuity will be added to the total check before the $5 is subtracted. So, you would have the bill, which is X, but they're going to add a 15% gratuity. So you get 1x plus this would be 1.15x. All right, the g of x is going to subtract $5. So the function that would represent this is g of 1.15x. You have the 15% gratuity added first, and then you take off $5. So that would be what was needed. Okay. You work 40 hours per week at a furniture store. You receive $220 weekly salary plus 3% commission on sales over $5,000. You sell enough to make a commission this week. What composite function will be needed to represent my commission? For this one, guys, I might actually work backwards a little bit, because it's saying I get $220 weekly salary plus a 3% commission on sales over $5,000. So I have to sell $5,000 before that even comes in. All right, so let's say that my sales are what they are. I would have to subtract off $5,000 from my sales. Let's make that something else. That's not looking real good. I guess I could make commission. We'll do that. Commission. C are my sales for the week. Okay. So we'll have commission minus 5,000 and 0.03 times that. That would give me my commission. That would give me my function to find my commission. So if I had to do this for an SAT where I would need to do it, I would work backwards. What does it mean? So I would have g of f of x to get to this point, which would mean my f of x would be c minus 5,000. That would be my f of x. And then my, well, actually, it's an f of c. So that's going to be f of c, and we can get this done. All right. F of c is c minus 5,000. So we'd have g of c is going to be 0.03 c. So g of f of c would be 0.03 times c minus 5,000. Sometimes it helps to work backwards and just think, this is what I need to figure out to get this kind of a function. And they will do that to you on some problems. Okay, your computer screensaver is an expanding circle. The circle starts as a dot in the middle of the screen and expands outward, changing colors as it grows. With a 21-inch screen, you have a viewing area with a 10-inch radius, measured from the center diagonally down to the corner. The circle reaches the corners in 4 seconds. What composite function would be needed to find the area as a function of time? All right, so if it reaches it in 4 seconds, you've got 10 inches divided by 4 seconds, which means it is running 2.5 inches per second. Okay? So my radius, in terms of time, is expanding 2.5 t. Okay? Area of a circle is always in terms of r, and it's pi r squared. So if you're going to take this in, that's going to be a of r of t that we're going to be doing then. So you will have a of 2.5t, which gives you pi times 2.5 t squared, or 6.25 pi t squared. That would be the composite function that you would need right there. Okay. I did get these questions from purplemath.com. So if you need any extra help, that would be where to go. It's right on the bottom of your screen. I did cite them. So I will see you next time.